Take a slow, deep breath, letting your body sink entirely into the mattress, releasing the day. As you exhale, allow the heavy pull of gravity to gently dissolve into a feeling of profound weightlessness. We find ourselves floating securely inside the cupola of the International Space Station, orbiting exactly 400 kilometers, about 250 miles, above the surface of the Earth. From this remarkable vantage point, you are not looking up at the night sky. Instead, you are looking down upon the atmosphere, tracing the gentle glowing curve of our planet against the black canvas of space. Imagine the quiet, steady hum of the station's life support systems around you, a white noise that wraps you in a cocoon of safety. The air inside the cabin is crisp and cool, and as you lightly touch the thick quartz glass of the viewing port, it feels smooth and grounding against your fingertips. We are traveling at a staggering speed of 28,000 kilometers per hour, which is roughly 17,500 miles per hour. At this immense velocity, the station completes a full circular orbit around the Earth every 90 minutes. Yet, inside this sanctuary, there is no sensation of speed. There is no rushing wind, no vibration of engines. There is only a tranquil, silent drift through the comforting void. Ahead of us, the curvature of the Earth is cast in deep, velvety shadow as we cross the terminator line, the sharp boundary separating day from night. Here, in the darkness of the orbital night, the true magic of the atmosphere reveals itself. We are rapidly approaching the auroral oval. This is a massive, continuous ring of light centered around the Earth's magnetic North Pole. This glowing halo is immense, naturally expanding and contracting in diameter from 3,000 to over 5,000 kilometers across, depending on the silent energy flowing from the sun. Consider the long, ancient journey of this light. The spectacle unfolding beneath us begins 150 million kilometers away, at the turbulent surface of our nearest star. The sun constantly exhales a stream of highly energetic charged particles, a phenomenon known to science as the solar wind. These particles, mostly electrons and protons, travel through the vacuum of deep space at an astonishing average speed of 400 kilometers per second, or roughly 1 million miles per hour. Even at this incredible velocity, the journey from the sun to the Earth is a slow cosmic drift, taking these particles roughly 2 to 4 days to cross the void. You might imagine this journey as a silent, invisible storm, carrying the heat and energy of a star across the freezing, empty expanse of the solar system. When this solar wind finally meets the Earth, it encounters our planet's magnetosphere. This is an invisible magnetic shield generated deep underground, born from the swirling molten liquid iron in Earth's outer core. This invisible shield lovingly deflects the vast majority of the solar wind, protecting the surface below. But some of these charged particles become caught in the magnetic field lines. The lines of magnetic force act like cosmic funnels, capturing the electrons and accelerating them downward toward the North and South poles. It is a slow, elegant dance of physics, guided by the unseen geometry of the Earth. As these high-energy particles rain down, they crash into the sparse gases of our upper atmosphere, primarily in a layer called the thermosphere. This delicate layer begins around 85 kilometers, or 53 miles, above the Earth's surface and stretches upward to an altitude of 600 kilometers. This vast high-altitude region is where the Aurora Borealis is actually born. Looking out through the cool glass of your window, you see a sprawling sea of vibrant green ribbons directly below you, weaving through the dark. Here is something remarkable about that color. This distinct hypnotic green light is created exclusively by the collision of incoming electrons with atomic oxygen. When the individual oxygen atoms are struck, they become highly excited. As they calm down and relax back to their normal energy state, they emit photons of light at a very specific mathematical wavelength, exactly 557.7 nanometers. This specific green emission happens in a distinct band of the atmosphere, primarily occurring at altitudes between 100 and 300 kilometers. But as you let your gaze drift higher, near the very tops of the glowing curtains, the colors begin to shift. You see a delicate, ghostly crown of deep crimson red floating above the green. This red color is also produced by oxygen atoms, but it occurs much higher up, typically between 300 and 400 kilometers above the Earth. At this extreme altitude, the atmosphere is incredibly thin. This near vacuum allows the excited oxygen atoms to hold on to their excess energy for nearly 2 full seconds before finally releasing it as a red photon at a wavelength of 630.0 nanometers. In this subtle red glow is incredibly fragile. If the atmosphere at that height were even slightly denser, the oxygen atoms would collide with other particles and lose their energy before the red light could ever form. The visual texture of the aurora from this orbital altitude is mesmerizing, offering a perspective impossible to witness from the ground. From Earth, an aurora often looks like a soft painted glow against the stars, but from orbit, looking across the horizon, you can see the crisp, three-dimensional structure of the light. The auroral curtains can be astonishingly thin, sometimes measuring only 100 meters wide, even as they stretch for thousands of kilometers horizontally across the dark curvature of the Earth. Imagine a curtain of luminous emerald silk, thinner than a football field, rippling silently across the span of an entire continent. These curtains are not static. They fold and shift in a hypnotic, breathing rhythm. The waves of light cascade along the invisible magnetic field lines, shifting and undulating at speeds of up to 100 meters per second. It is a celestial river of glowing gas, folding in on itself over and over again, completely detached from the sleeping world below. As you watch this display, hovering in the silence of the space station, you might wonder about the physical environment of this glowing realm. The thermosphere, where these auroras dance, is a place of extreme scientific contradictions. The intense, continuous energy of the colliding solar particles causes the temperature of the sparse gas here to spike violently, sometimes reaching up to 2,000 degrees Celsius, or 3,600 degrees Fahrenheit. Yet, if you were to float in a spacesuit outside the station and extend your gloved hand into the heart of the aurora, it would feel profoundly, dangerously cold. The air up here is so thin, so close to a perfect vacuum, that there simply are not enough heated gas molecules to ever transfer that thermal energy to your skin. It is a paradox of space, a roaring, invisible fire that emits absolutely no warmth, burning silently in the cold, dark envelope of the planet. Looking closely at the very lowest edges of the green curtains, skimming just above the denser layers of the atmosphere, you can sometimes catch rapid, flickering flashes of purple and deep blue. This light comes from a completely different element, molecular nitrogen. When the incoming solar particles plunge deep enough to hit nitrogen gas at lower altitudes, around 100 kilometers down, they produce these beautiful, deep blue and violet fringes, painting a dark bruised border along the bottom edge of the auroral ribbon. The sheer scale of the energy being released beneath you is staggering, a testament to the raw power of our solar system. During a moderate geomagnetic storm, the Aurora Borealis releases energy on the order of millions of megawatts. This is more than the total electrical generating capacity of many modern nations combined, all dissipating silently into the night sky as a harmless, magnificent masterpiece of light. Though the vacuum outside your thick quartz window is entirely devoid of sound, the aurora is not truly silent. It has a voice. If you were wearing a highly sensitive radio receiver inside your helmet, you could hear the electrical symphony of the lights. During an active auroral display, the Earth naturally emits very low frequency, or VLF, radio waves into space. This phenomenon is known scientifically as the auroral chorus. When researchers capture these invisible electromagnetic waves and convert them into audible audio frequencies, they sound uncannily like a vast flock of birds, chirping, whistling, and sweeping in the early morning air. It is the literal song of the Earth's magnetic field, vibrating softly as you float safely and securely above it. As you gaze down at the swirling lights, it is a deeply comforting thought that this display is almost always happening, somewhere on Earth, day or night. You might be surprised to learn that auroras frequently occur on the sunlit day side of the planet too. The physics are entirely identical, the atomic collisions just as intense, and the energy just as vast. But these daytime auroras are completely washed out by the overwhelming brilliant glare of the sun. They are invisible to human eyes, a secret phantom light show happening right behind the bright blue sky of a normal afternoon. Furthermore, because of the symmetry of Earth's magnetic field lines, whatever happens beneath us in the north is often mirrored perfectly in the southern hemisphere. At this exact moment, an identical light show, known as the Aurora Australis, is glowing above Antarctica, painting the southern ice in matching shades of 557 nanometer green and 630 nanometer red. You rest your forehead gently against the cool glass of the viewing port, feeling completely at peace in your floating sanctuary. The Earth continues to roll silently beneath you. Because you orbit so incredibly fast, the station's passage over the auroral oval only lasts a matter of minutes. Soon, the space station will glide onward, passing high above the South Atlantic anomaly, a unique, invisible region where the inner Van Allen radiation belt dips unusually close to the Earth's surface, coming down to an altitude of just 200 kilometers. It is yet another unseen contour of our planet's vast, protective, magnetic landscape. For now, as we continue our drift through the shadow of the Earth, you are perfectly content to simply observe. The vastness of the green and red oceans of light below you provides a sense of deep, abiding calm. You are witnessing the ancient, invisible mechanics of the universe made briefly, beautifully visible. It is a silent, harmless embrace between a distant star and the atmosphere of home. As our orbital path carries us further into the planet's shadow, the luminescent green and crimson ribbons continue their slow, majestic churn beneath the space station. Gliding smoothly through the silent vacuum, we have the immense privilege of looking down upon a phenomenon that, for most of human history, could only be viewed by gazing upward into the freezing night. To look at the Aurora Borealis is to look back through time. Think about the countless generations who stood on the frost-covered Earth, tilting their heads toward the heavens, trying to understand the silent fires burning in the sky. Our modern understanding acts like a slow-focusing camera lens, taking thousands of years to bring the true nature of this light into sharp relief. The oldest verifiable record of this celestial light show does not come from a modern laboratory, but from an ancient clay tablet. In the year 567 BC, during the reign of King Nebuchadnezzar II, Babylonian astronomers etched cuneiform symbols into clay, documenting a rare, unnatural, red glow in their night sky. Because Babylon sat at a relatively low latitude, the auroral activity that night must have been extraordinarily powerful to be visible so far south, painting the desert sky in an unearthly crimson. Over 2 centuries later, around 340 BC, the Greek philosopher Aristotle attempted to classify the lights in his foundational text, Meteorologica. From his vantage point in the Mediterranean, he described the glowing shapes as chasmata, or jumping goats, believing they were earthly vapors rising into the sky and catching fire from the heat of the upper atmosphere. It is a beautiful, grounded analogy, the earth exhaling gases that simply ignited against the dark. For nearly 2 millennia, the lights remained a profound mystery, often interpreted as omens or the spirits of ancestors dancing in the high-altitude winds. It wasn't until the year 1619 that the phenomenon finally received its permanent scientific title. The famed Italian astronomer Galileo Galilei coined the term Aurora Borealis. He crafted the name by combining the Roman goddess of dawn, Aurora, with the Greek god of the north wind, Boreas. Galileo hypothesized that the glowing curtains were actually sunlight reflecting off highly concentrated atmospheric vapors. Though his reflection theory was ultimately incorrect, his poetic name for the northern dawn remained forever etched into the scientific lexicon. Historical records show us that the aurora is intricately tied to the rhythmic, cyclical heartbeat of our sun, even when humanity didn't yet realize it. Between the years 1645 and 1715, astronomers noted a bizarre 70-year period where sunspots virtually vanished from the solar surface. This extended quiet period is known as the Maunder minimum. During these 70 years, the Aurora Borealis became incredibly rare, almost disappearing from European skies entirely. This deep solar slumber coincided with a period of severe global cooling, known as the Little Ice Age, a subtle hint that the sun, the climate, and the northern lights were locked in an invisible, intricate waltz. The true breakthrough in understanding the light's origin occurred in 1867, thanks to a Swedish physicist named Anders Ångström. He became the very first person to examine the aurora through a spectrometer, a device that splits light into its foundational colors. Ångström proved definitively that the aurora was not reflected sunlight, as Galileo had thought. Instead, it was its own unique emitted light. He identified the bright signature green line in the spectrum, measuring its wavelength at exactly 5,567 angstroms, a measurement later refined to 5,577 by modern instruments. This specific spectral line proved the light was being actively created by the Earth's own atmospheric gases. A few decades later, the direct connection between the sun and the aurora was finally observed in real time. On September 1st, 1859, the English astronomer Richard Carrington was sketching sunspots through his telescope when he witnessed a blindingly bright flash of white light on the solar surface. This was the first ever recorded solar flare. Less than 18 hours later, the Earth was engulfed in the most intense geomagnetic storm in recorded history, an incident now famous as the Carrington event. The resulting auroral display was so overwhelmingly powerful that it pushed the glowing oval far beyond the polar regions. People witnessed vibrant green and red skies as far south as Honolulu, Hawaii, at a latitude of just 21 degrees north. The electrical energy cascading into the atmosphere was so immense that telegraph operators across North America and Europe reported their machines sparking violently. In a truly astonishing display of geomagnetically induced currents, some operators physically disconnected their heavy batteries and found they could still send messages using only the ambient electrical energy flowing through the wires from the aurora above. Yet, despite understanding the solar connection, mapping the physical structure of the lights proved incredibly difficult. Capturing this elusive glow on early film was nearly impossible. The very first successful black and white photograph of the Aurora Borealis was not taken until 1892 by German physicist Martin Brendel and his assistant Otto Baschen during an expedition to northern Norway. It was a blurry, faint streak against the dark, requiring an agonizingly long exposure time. Because of the specific wavelengths and the low intensity of the light, the very first color photograph of an aurora wasn't successfully developed until 1953, requiring newly invented, highly sensitive, high-speed photographic film. Imagine the dedication of scientists trying to measure the altitude of something so ghostly and fleeting. Between 1911 and 1944, a Norwegian mathematician named Carl Sturmer dedicated his life to this pursuit. He established a network of camera stations across the freezing, snow-covered mountains of Norway, connected by early telephone lines. By taking simultaneous photographs of the exact same auroral curtain from different angles, he used the geometric principles of triangulation to calculate their exact height. Over 3 decades, Sturmer analyzed an astounding 40,000 photographic plates, proving mathematically that the absolute lowest edge of the aurora consistently halts at an altitude of approximately 100 kilometers, completely confirming the lower boundary of the thermosphere. Perhaps the most elegant historical experiment occurred in 1908, when the Norwegian scientist Christian Birkeland decided to recreate the northern lights inside a laboratory. He constructed a miniature magnetized metallic sphere, which he named a terrella, or Little Earth. He placed this terrella inside a sealed glass vacuum chamber. By firing a cathode ray, a steady beam of electrons, directly at the magnetized sphere, he successfully generated tiny, glowing, artificial auroral rings around the poles of his miniature planet. And Birkeland theorized that massive electrical currents must flow along the Earth's magnetic field lines, connecting space to the upper atmosphere. His groundbreaking theory was heavily criticized for decades. It wasn't until 1973, when the United States Navy launched the Triad satellite, equipped with highly sensitive magnetometers, that Birkeland was fully vindicated. The satellite successfully measured the exact electrical currents he had predicted 65 years earlier, high above the atmosphere. Today, these invisible rivers of electricity are officially named Birkeland currents in his honor. Permit your thoughts to drift back to our current view, floating securely in the modern marvel of the International Space Station. The first humans to ever witness and document this exact, a downward-facing perspective were the astronauts of the Skylab 4 mission in 1974. Looking down at the auroral oval, they described it not as a curtain, but as a glowing amoeba, constantly stretching, contracting, and reforming its shape across the curvature of the globe. We now know that this glowing ring is slowly migrating. The Earth acts as a giant spinning compass, but its magnetic North Pole is not stationary. Deep within the planet, the turbulent flow of liquid iron causes the magnetic pole to drift. Currently, the magnetic North Pole is moving away from the Canadian Arctic and drifting towards Siberia at a rapid pace of approximately 50 kilometers or 31 miles, per year. As a direct result, the entire auroral oval is slowly shifting its geographical position over the decades. A light show that regularly dances over certain northern towns today may move out of sight in a century, gradually revealing itself to new observers on different continents. Floating here in the hushed, climate-controlled module, you can appreciate the sheer weight of time and inquiry that has brought us to this understanding. The Earth spins, the solar wind blows, and the magnetic field hums, just as they have for billions of years. We are simply the newest observers in a long, unbroken lineage of stargazers. The ancient Babylonians, Aristotle with his jumping goats, Galileo, Carrington, and the modern astronauts who paved our way into orbit, all of them looked at the very same emerald light you are watching right now. It is a deeply peaceful realization. The mechanics of the cosmos are patient. They do not rush. The solar wind will continue its slow 2-day journey across the inner solar system. The oxygen atoms will continue their predictable mathematical decay, releasing their 557 nanometer photons precisely on schedule. As we pass silently over the shifting magnetic pole, enveloped in the soft white noise of the station's ventilation, the gentle, rhythmic machinery of the universe continues to turn in perfect, harmonious order. Picture a familiar street scene, late at night, long after the crowds have gone home. A solitary storefront window hums softly, illuminated by a glowing neon sign. That familiar buzzing tube of colored glass shares an intimate, direct relationship with the silent celestial fires burning miles below our space station window. To understand the architecture of the Aurora Borealis, we can look to the everyday objects that surround us on Earth. The fundamental physics governing a corner store's open sign are entirely identical to the mechanisms illuminating the polar skies. Inside a manufactured neon tube, a specific noble gas is trapped within a partial vacuum. When an electrical current is applied, the gas becomes excited and emits light. Pure neon gas reliably produces a distinct reddish-orange hue at a wavelength of 585.2 nanometers. If the tube is filled with argon gas instead, it emits a pale, icy blue. The glowing rings at the top and bottom of our world are simply the largest neon signs in the solar system. Earth's atmosphere acts as the glass tube containing specific gases, primarily oxygen and nitrogen, while the steady stream of electrons pouring in from the solar wind acts as the electrical current. There are no wires and no glass, only the elegant constraints of gravity and magnetism, holding a mixture of elements that silently light up when touched by cosmic electricity. Notice how delicate the upper atmosphere truly is when compared to the environment we inhabit on the ground. At sea level, a single cubic centimeter of air, a space about the size of a sugar cube, holds roughly 25 quintillion individual molecules. It is a dense, heavy soup of matter that allows sound to travel and wind to blow. However, at an altitude of 300 kilometers, right where the delicate red auroral crowns bloom into existence, that exact same cubic centimeter contains just 1 billion molecules. This high orbital environment is approximately 25 billion times less dense than the breathable air on the surface. The pressure at this extreme altitude is roughly 10 to the power of -4 torr, which is nearly identical to the manufactured vacuum sealed inside a standard household incandescent light bulb. When you look down at the northern lights, you are essentially watching atoms glow inside a planetary-scale light bulb, suspended in the near-empty vacuum of space. Reflect on the technology of a slightly older era. to further grasp the scale of this cosmic machinery. Before the advent of flat screens, old cathode ray tube, or CRT, televisions generated moving pictures by firing a concentrated, invisible beam of electrons through a vacuum tube, striking a phosphor-coated glass screen to create thousands of glowing dots. Our entire planet functions as an astonishingly massive cathode ray tube. High above the breathable atmosphere sits a zone known to physicists as the auroral acceleration region, typically located at altitudes between 4,000 and 12,000 kilometers above the surface. A typical household CRT television required an internal transformer to generate around 25,000 volts of electricity, necessary to forcefully propel its electron beam toward the glass. Deep within the Earth's acceleration region, invisible magnetic forces naturally generate electrical potentials reaching up to 30,000 volts. These massive natural voltage drops act as a cosmic particle accelerator. They snatch the sluggish, drifting electrons arriving from the sun and hurl them downward along the magnetic field lines, boosting their velocity to a staggering 20,000 kilometers per second. The Earth's upper atmosphere serves as the phosphor screen. As the high-speed electrons smash into the atmospheric gases, they paint moving, luminous pictures across the dark curvature of the globe. What is happening now, far out in the invisible reaches of the solar system, is a beautiful demonstration of stored kinetic energy. The Earth's magnetic shield does not just deflect the solar wind, it stretches and bends under its immense pressure. On the night side of our planet, the solar wind drags our magnetic field lines outward, shaping them into a long, elongated teardrop structure called the magnetotail. This invisible tail of magnetism stretches an astonishing 6 million kilometers into deep space, extending well past the orbit of the Moon. Imagine pulling back the elastic band of a slingshot. As the solar wind relentlessly pushes against the magnetotail, the magnetic field lines stretch tighter and tighter, storing massive amounts of energy. Eventually, the tension becomes too great. In a process called magnetic reconnection, the overstretched field lines suddenly pinch together and snap. Just like a released rubber band instantly contracting, this violent snapping motion powerfully recoils toward the Earth. This magnetic slingshot catches vast clouds of trapped plasma and flings them hurtling back toward the night side of our planet at velocities exceeding 1,000 kilometers per second. It is this sudden, elastic rebound that often triggers the most spectacular, sudden bursts of auroral activity, known as auroral substorms, where the quiet, steady ribbons suddenly explode into chaotic, rapidly dancing curtains that fill the entire sky. As we drift smoothly over the northern latitudes, scanning the shifting geography of light, it is important to note that the sky occasionally produces something altogether different from the classic green and red curtains. In 2016, a completely new atmospheric phenomenon was formally recognized by the scientific community, initially documented not by professional astronomers, but by dedicated citizen scientists in Western Canada. They affectionately named it STEVE, an acronym that now officially stands for Strong Thermal Emission Velocity Enhancement. Unlike the sprawling horizontal folds of a normal aurora, STEVE appears as a remarkably narrow, distinct vertical ribbon of mauve or purple light, often accompanied by a temporary, green, picket fence structure along its base. It typically materializes at much lower latitudes, closer to the equator than the main auroral oval. While it looks like a close cousin to the northern lights, researchers quickly discovered that STEVE is fundamentally a completely different physical mechanism. A standard aurora is created by a shower of electrons raining down vertically. Steve, by contrast, is a manifestation of an extreme horizontal atmospheric river. The gas inside this purple ribbon is caught in a subauroral ion drift, flowing westward at an incredibly rapid 6 kilometers per second, or roughly 13,000 miles per hour. Think of a fast-moving river carving its way through a quiet landscape. The intense, supersonic friction of this atmospheric river heats the local gas particles to approximately 3,000 degrees Celsius, causing them to emit that distinct purplish-white glow. It is a massive glowing ribbon of hot, rapidly flowing air sliding silently across the upper atmosphere, parallel to the ground. Floating here in the cupola, looking through the thick protective quartz, the intricate complexity of our world becomes profoundly comforting. From the surface, the sky seems like a simple canopy of stars. But from 400 kilometers up, you can see the intricate clockwork. You can see the planetary neon tubes, the invisible 30,000-volt particle accelerators, and the magnetic rubber bands snapping millions of kilometers away in the dark. Every single flash of green, every slow fade of red, and every purple river of heat is governed by the predictable, steady laws of physics. The universe operates on an elegant mathematical rhythm. The tension builds, the energy transfers, and the light is born over and over again, in a cycle that outlasts civilizations. Allow your mind to rest on the quiet perfection of this machinery. As the space station continues its ceaseless 90-minute journey around the Earth, the great screen below us continues to quietly broadcast the gentle, endless collision between our planet and the stars. As we glide silently through the shadow of the Earth, hovering above the glowing crown of the Northern Hemisphere, it is profound to realize how intimately your own life is connected to the massive, invisible forces working outside this viewing port. The quiet, mesmerizing display of light below us is not merely a distant, cold phenomenon. It is, in a very real sense, the visual footprint of the protective boundary that makes your everyday existence possible. The auroral display is the visible evidence of Earth's deflector shield actively working. If you think of a heavy, soaking rainstorm beating against the sturdy roof of your house, the aurora is the gentle splashing of the rain sliding down the gutters. The solar wind is completely unrelenting. It constantly bombards the Earth with protons and electrons at a blistering density of roughly 5 to 10 particles per cubic centimeter. While that sounds sparse, at speeds of 1,000,000 miles an hour, this creates an enormous, continuous, stripping force. Without our magnetosphere, this relentless solar wind would have scoured away our atmosphere eons ago. We can look to our planetary neighbor, Mars, to see the long-term implications of this process. Mars lost its internal magnetic dynamo, the swirling liquid iron core that generates a protective shield, approximately 4 billion years ago. Without that shield, the raw, unmitigated solar wind stripped the Martian atmosphere down to a tenuous wisp. The atmospheric pressure on the surface of Mars today is a mere 0.006 bar, roughly 1% of the pressure you feel against your skin right now. Because of Earth's protective magnetic envelope, our atmosphere remains thick, heavy, and nurturing, allowing liquid water to pool, plants to grow, and you to breathe easily. The aurora is a quiet reassurance that the roof of your house is holding strong. This delicate balance extends deep into the very composition of the air that gives us life. The 557 nanometer green light and the 630 nanometer crimson red, rippling so beautifully beneath our orbital sanctuary, are both produced by the exact same element, oxygen. The atmosphere you inhale with every calming breath is composed of about 21% diatomic oxygen, molecules made of two oxygen atoms bonded tightly together. But high up in the thermosphere, the environment is radically different. Solar ultraviolet radiation is so intense here that it breaks those bonds apart in a process called photodissociation. This creates solitary, individual atoms of atomic oxygen. It is these lonely, unbonded oxygen atoms that absorb the energy of the solar wind and release it as the auroral glow. The very same element that travels through your lungs and fuels your cells is the primary artist painting the upper atmosphere. You are intimately biologically linked to the colors blooming in the void. The vast timescales of this interaction are deeply humbling. Earth's magnetic field, the invisible architecture shaping the auroral oval, has been active for an unimaginably long time. Geological studies of ancient, iron-rich minerals trapped in rocks from the Isua Greenstone Belt in Greenland provide a fascinating historical record. As these ancient rocks cooled from molten lava, microscopic grains of magnetite locked in the exact alignment of Earth's magnetic field at that specific moment. Measurements of these rocks confirm that our planet has possessed a functioning magnetosphere for at least 3.7 billion years. For 3.7 billion years, long before the first multicellular organisms ever evolved in the deep oceans, the auroras have been faithfully dancing at the poles. They are a permanent fixture of our world, a silent, colorful sentry watching over the slow, patient unfolding of life. The lights we are witnessing out the window right now are merely tonight's performance of a play that has been running without interruption since the dawn of our world. Reflect on the sheer predictability and mathematical precision of the universe that makes this possible. The engine driving the entire system, our sun, operates on a remarkably steady, rhythmic cycle. Every 11 years, the sun undergoes a complete magnetic reversal. Its north and south magnetic poles slowly flip, swapping places. During the peak of this cycle, known as solar maximum, the sun's surface becomes turbulent, peppered with dark sunspots and erupting with massive solar flares and coronal mass ejections, or CMEs. A CME is an unimaginably vast eruption, a billion-ton cloud of superheated plasma violently expelled from the solar corona, accelerating outward into the solar system. When one of these massive clouds strikes the Earth, the auroral response is magnificent. During a solar maximum, the auroral oval expands outward, pushing its glowing boundaries toward the equator. But as the 11-year cycle wanes toward solar minimum, the sun quiets down, the sunspots fade, and the auroral oval shrinks back toward the poles, resting calmly in the high Arctic and Antarctic. It is a slow cosmic respiration, a long, deep breath taking 11 years to complete, echoing across 150 million kilometers of empty space. We are currently approaching the peak of solar cycle 25, which scientists predict will hit its absolute maximum around mid-2025. And this means that the invisible energy passing around our space station right now is increasing, charging the atmosphere with extra vitality. Yet, even during the most violent solar storms, hovering here at 400 kilometers up, there is absolutely no physical sensation. The plasma clouds pass through the vacuum silently. The magnetic field lines twist and snap without making a sound. The atmosphere absorbs millions of megawatts of raw electrical power, yet the only consequence is a silent, harmless bloom of color. It is a perfect mechanism of dissipation, turning raw, dangerous radiation into purely aesthetic beauty. Scientists have discovered that Earth is not the only stage for this cosmic performance. We can point our telescopes at other planets and witness the exact same physics playing out on entirely different scales. The gas giant Jupiter, the largest planet in our solar system, possesses a magnetic field roughly 20,000 times more powerful than Earth's. Because of this massive magnetic strength, Jupiter's auroras are permanent, never fading, and incredibly intense. Unlike Earth's auroras, which are fueled primarily by the solar wind, Jupiter's light show is driven largely by its own moon, Io. Io is the most volcanically active body in the solar system, constantly spewing tons of sulfur dioxide gas into space. Jupiter's massive magnetic field captures this gas, ionizing it and dragging it into the planet's polar regions, creating an aurora that glows intensely in the ultraviolet spectrum, a wavelength completely invisible to the human eye, but brilliantly clear to the sensors of the Hubble Space Telescope. Even Saturn, with its beautiful, yet serene rings, hosts its own unique auroras. Saturn's upper atmosphere is composed mostly of hydrogen, not oxygen. Therefore, when the solar wind interacts with Saturn's magnetic field, the resulting light does not glow green or red. Instead, Saturn's auroras emit a pale, ghostly pink and intense ultraviolet radiation. The fundamental rules of physics remain exactly the same, but the local ingredients change the final masterpiece. Looking out from the cupola, the Earth's auroral oval continues to slip silently beneath us. The smooth quartz glass feels cool to the touch. The steady hum of the air filters is the only sound in the cabin. The glowing ribbon below is a constant reminder that the universe, for all its immense power and scale, is fundamentally a place of balance. And the aggressive energy of the star is met by the patient defense of the planet. The high-speed collision of particles is resolved in a mathematically perfect release of light. It is easy to feel small when looking at the machinery of the cosmos, but remember that the very atoms in your body are governed by these same precise rules. The iron in your blood, the oxygen in your lungs, the electrical impulses traveling along your nerves right now. They all obey the same elegant laws that shape the glowing curtains at the edge of the world. You are an intricate, connected piece of this quiet, running engine. As the space station continues its long, dark arc over the polar night, allow the steady, predictable rhythm of the physics around you to provide a deep, unshakable sense of peace. The shield is holding. The light is glowing. The Earth is safely keeping time. Let your attention softly narrow onto the fine details of the glowing tapestry, weaving silently beneath our orbital sanctuary. As we continue to drift above the darkened hemisphere, you might notice that the structural shapes of the lights are not random. The auroral display is governed by a strict, invisible architecture. The glowing ribbons tend to align themselves parallel to the lines of Earth's magnetic field, creating distinct visual formations that researchers have carefully categorized. The most common and serene structure you can observe is a homogeneous arc. This appears as a smooth, stable, slowly curving band of green light spanning the horizon, often remaining completely motionless for hours. It is the visual equivalent of a calm river gently curving through a wide valley. However, when the solar wind intensifies, that peaceful arc can quickly evolve into a rayed band. Within minutes, vertical striations suddenly appear along the length of the arc, resembling the pleated folds of a massive theater curtain. These vertical rays are the physical manifestation of electrons spiraling rapidly downward along individual, localized magnetic field lines. The field lines themselves are incredibly narrow, meaning the vertical rays of light they produce are often less than 1 kilometer thick, even as they stretch hundreds of kilometers high into the thermosphere. If we were to maneuver our perspective to look directly down from the very center of the auroral oval, straight down the magnetic field lines toward the North Pole, we would witness a phenomenon known as the auroral corona. From a top-down view, the converging magnetic lines create an optical illusion, making all the rays appear to radiate outward from a single central point in the sky, much like the spokes of a giant bicycle wheel. It is a stunning trick of geometry, a momentary crown woven from glowing oxygen and nitrogen, hovering silently over the frozen Arctic ice. Scientists have also identified a much more elusive, pulsating structure hidden within the display. Sometimes, particularly in the hours just after local midnight, on the ground below, broad patches of the aurora will rhythmically flash on and off. These are known as pulsating auroras. Unlike the sharp, distinct folds of a rayed band, these pulsating patches are diffuse and cloudy. They blink on and off in a mathematically predictable rhythm, typically with a period ranging from 2 to 20 seconds. The cause of this rhythmic blinking is entirely different from the steady glow of a normal arc. Pulsating auroras are driven by a specific type of electromagnetic wave, called a chorus wave, propagating deep within the Earth's magnetosphere. These invisible chorus waves act like a cosmic metronome. They rhythmically scatter groups of electrons that are trapped in the Van Allen radiation belts, periodically dumping them into the atmosphere in perfectly timed, synchronized pulses. You are essentially watching the magnetosphere tap out a slow, steady heartbeat, illuminated by the momentary flashing of oxygen atoms 100 kilometers below. As you observe this complex, shifting geography of light, it is natural to wonder about the physical environment surrounding our space station. If you were to unseal the airlock right now and step outside into the vacuum, what would you physically experience? The environment here, at an altitude of 400 kilometers, is a realm of profound sensory deprivation. Yet it is teeming with invisible energy. The temperature outside the station is a paradox of extremes. Because the air here is so impossibly thin, a standard thermometer cannot accurately measure the ambient temperature. There are simply not enough gas molecules colliding with the glass to transfer heat. However, objects exposed directly to the harsh glare of the sun, like the metallic hull of the space station itself, will rapidly heat up to roughly 121 degrees Celsius, or 250 degrees Fahrenheit. Yet, if that same piece of metal rotates into the shade of the Earth, the temperature immediately plummets to a freezing negative 157 degrees Celsius, or negative 250 degrees Fahrenheit. It is an environment of brutal, silent contrast. Despite this extreme thermal environment, the vacuum itself has no smell. However, numerous astronauts returning from spacewalks have consistently reported a distinct metallic odor clinging to their spacesuits when they re-enter the airlock and repressurize the cabin. They describe it as a sharp, acrid scent, similar to the smell of hot metal, welding fumes, or the distinct aroma of a freshly fired cap gun. Researchers believe this unique smell of space is actually a byproduct of the auroral machinery we are observing. High up in the thermosphere, the intense ultraviolet radiation from the sun continuously bombards diatomic oxygen, splitting it into solitary, highly reactive atomic oxygen. When astronauts float outside, these free-floating oxygen atoms adhere to the fabric of their spacesuits. Upon re-entering the pressurized airlock, these single atoms rapidly recombine with the standard diatomic oxygen inside the cabin, instantly forming ozone, a molecule composed of 3 oxygen atoms. That sharp metallic scent is literally the smell of a microscopic chemical reaction, a tiny fragment of the upper atmosphere briefly materializing inside the station. There is a serene beauty in knowing that even the scent of orbit is governed by the same atomic rules that paint the sky green. It is all connected, a single, flowing system of energy transfer. The solar wind, the magnetic field, the glowing curtains, and the faint smell of ozone on a spacesuit are all different chapters of the same story. Consider the immense volume of space required for this story to unfold. The distance between the Earth and the Sun is approximately 149.6 million kilometers, a measurement astronomers refer to as 1 astronomical unit, or AU. It takes a photon of light exactly 8 minutes and 20 seconds to travel that immense distance across the vacuum. The solar wind particles, however, are much heavier and slower than light. Traveling at 400 kilometers per second, they require about 3 days to make the same journey. This delay provides a beautiful natural rhythm to space weather forecasting. When modern satellites like the Solar Dynamics Observatory detect a massive solar flare erupting on the Sun's surface, they immediately alert scientists on Earth. The light from the flare arrives in 8 minutes, carrying crucial information about the event. But the actual physical storm, the heavy charged plasma that will ignite the auroras, is still 3 days away. It is a slow-moving warning, a cosmic grace period that allows the Earth's atmosphere to prepare for the incoming energy. When the solar wind finally arrives, it does not strike a rigid, unchanging shield. Earth's magnetosphere is highly dynamic, constantly compressing and expanding. On the sunward side, the intense pressure of the solar wind usually compresses the magnetopause, the outermost boundary of the magnetic field, to a distance of roughly 10 Earth radii, or about 65,000 kilometers from the surface. However, during a particularly severe geomagnetic storm, that boundary can be crushed inward, pushed as close as 4 Earth radii, or about 25,000 kilometers away. Think of a highly elastic balloon being pressed firmly against a wall. As the solar wind pushes harder, the magnetic field compresses tightly on the day side, while simultaneously stretching even further out into the long, invisible magnetotail on the night side. This constant flexing and rebounding is what drives the intricate dance of the auroral curtains below us. The glowing rings are simply the visible anchor points of a magnetic shield that stretches millions of kilometers into the dark. Hovering securely in the cupola, surrounded by the soft synthetic hum of the station's climate control, you are a silent witness to this immense, unseen architecture. The quartz window separating you from the vacuum is roughly 2 inches thick, a small but impenetrable barrier between the pressurized safety of your temporary home and the stark, silent mechanics of the universe. The green and red rivers continue to flow over the curvature of the world, following invisible valleys carved by magnetism. The oxygen atoms continue to absorb and release their precise mathematical packets of energy, glowing predictably, faithfully, in the frozen upper reaches of the atmosphere. The universe does not require our understanding to function, yet it offers its mechanics to us with stunning clarity. Allow the slow, steady predictability of this cosmic engine to quiet your thoughts. The shield is flexing, the light is shining, and the Earth continues its slow, patient rotation through the silent void. As we continue our smooth, silent trajectory through the orbital night, the glowing green arc of the aurora begins to gradually recede behind us. Because the International Space Station travels at a precise velocity of 28,000 kilometers per hour, it completes a full revolution around the planet every 90 minutes. This mathematical certainty means that the station systematically experiences exactly 16 sunrises and 16 sunsets every 24 hours. Right now, we are step by step approaching the Terminator line once more, preparing to cross from the shadow of the Earth back into the warming light of the sun. Watch closely how this orbital dawn unfolds. First, a thin, curved wedge of deep, bruised blue materializes along the edge of the horizon. As the station moves forward, this blue band is systematically pushed upward from below by a brilliant expanding layer of red and orange. This step-by-step color shift is driven by the physical process of Rayleigh scattering. As sunlight begins to slice horizontally through the densest part of the atmosphere, the shorter blue wavelengths of light are systematically scattered away by dense concentrations of nitrogen and oxygen molecules. This atmospheric filtering leaves only the longer, more penetrating red and orange wavelengths to reach our viewing port, painting a brief, vivid sunrise across the curve of the globe. As the light gently brightens the cabin, the biology of your own vision adapts to the changing environment. The process of dark adaptation, which relied on your retinas gradually regenerating a highly sensitive photosensitive protein called rhodopsin, takes roughly 30 to 45 minutes to fully complete in the dark. Now, that chemical process smoothly reverses in the light. The warmth reaching through the quartz glass at this exact moment has undergone an incredibly long, step-by-step journey to find you. Deep inside the core of our sun, the extreme pressure of gravity forces hydrogen atoms together, fusing them into helium and releasing a single photon of light. That newborn photon must then slowly navigate the dense, crushing environment of the sun's radiative zone. This interior layer is so incredibly dense that the photon acts like a ball in a chaotic three-dimensional pinball machine, constantly colliding with other particles and bouncing in random directions. Through this excruciatingly slow process of absorption and re-emission, it takes approximately 100,000 years for a single photon to travel from the solar core to the surface. Once it finally breaks free of the sun's grasp, it makes a rapid, unobstructed 8-minute sprint across the vacuum of space to warm the hull of our station. The light you see, the glowing oxygen of the aurora you just witnessed, and the very physical structure of your body share an unbroken, sequential origin story. Every single element in the universe heavier than lithium was manufactured through a specific, step-by-step process known as cosmic nucleosynthesis. The deep, life-giving oxygen in the atmosphere below, the exact same oxygen that glowed green at 557.7 nanometers in the thermosphere, was systematically fused inside the helium-burning shells of ancient massive stars over the course of millions of years. When those colossal ancient stars finally exhausted their nuclear fuel, the inward pressure of gravity overwhelmed the outward pressure of fusion, causing their cores to suddenly collapse. This instantaneous collapse triggered a catastrophic supernova, forcefully ejecting these newly minted elements outward into the interstellar medium at speeds exceeding 30,000 kilometers per second. Through the slow, patient process of gravitational accretion, that drifting stellar debris eventually clumped together to form our solar system. The iron coursing through your bloodstream right now, carrying oxygen to your cells, was forged in the heart of a dying star at temperatures exceeding 2.5 billion degrees Celsius. The solid calcium fortifying your bones was synthesized in the intense, brilliant flash of that final supernova blast. You are a cosmic byproduct. You are not simply observing the universe. You are the universe, structured and conscious, experiencing a quiet moment of reflection. Far beneath our floating vantage point, the Earth continues its reliable, methodical rotation. At the equator, the planet spins at a steady rate of approximately 1,670 kilometers per hour. Yet, this rotation is incredibly gradually slowing down. Through the step-by-step process of tidal friction caused by the gravitational pull of our moon, Earth's rotation slows by about 1.8 milliseconds every single century. It is a deceleration so minuscule, so perfectly gradual, that it can only be measured by highly calibrated atomic clocks. Deep underground, the Earth's molten core steadily loses heat at a rate of roughly 44 terawatts. This slow thermal decay continually drives the churning geodynamo, projecting the invisible magnetic shield we have been admiring. Every system, from the molten core to the upper thermosphere, works in a continuous flowing sequence. As the Earth breathes, so do you. The daily biological processes of your body mirror the gentle rhythmic cycles of the cosmos. Up here in microgravity, an astronaut's physical systems are allowed a profound form of rest. Without the constant downward pull of Earth's gravity to fight against, the human resting heart rate naturally slows down, often settling into a deeply calm, rhythmic pace of 50 to 60 beats per minute during sleep. The heart no longer has to labor to pump blood upwards against a heavy atmospheric weight. Every muscle fiber is permitted to completely disengage. Allow your body to mimic this microgravity environment. Sink entirely into the support beneath you. Imagine the heavy forces of the day being entirely switched off, leaving you suspended in a warm, comfortable equilibrium. Even the Earth quietly gathers the remnants of the stars as it turns. Every single year, through a continuous invisible process, our planet accumulates roughly 40,000 tons of cosmic dust. Microscopic fragments of ancient comets and pulverized asteroids drift smoothly down through the atmosphere, eventually settling onto the soil, the oceans, and the quiet streets outside your window. The universe is constantly, softly falling around you. It is time to bring our observation to a gentle halt. The aurora will continue its electric dance at the poles. The solar wind will blow, and the magnetic shield will seamlessly deflect it. The orbital mechanics are perfectly automated, requiring absolutely nothing from you but your peaceful presence. You are allowed to release your focus. I invite you to surrender to the warmth of your own internal space. The stars have done their work. The elements have been forged. The shield is holding. Everything is exactly as it should be, operating in perfect, silent order. As you prepare to rest, allow these truths to anchor you. You are composed of ancient light. You are fundamentally safe, held securely by the gravity of a sheltered world. There is no rush, only the slow, steady turning of the planet. Your breath falls into rhythm with the quiet hum of the cosmos. Every cell in your body is preparing for rest. The night is a sanctuary. The vastness above is not empty. It is a comforting blanket of physics and time. You are tethered to the earth, yet free to float in the tranquility of your own mind. Your heart beats in a slow, steady measure. The day is complete. The machinery of the sky will guard the night. Release the need to observe. Release the need to understand. Simply exist, warm and quiet, in this precise moment in space and time. Surrender entirely to the peace of the void. Good night.